Yes, good evening, everyone. You are most welcome for the session. Do we have anyone who wants to lead us in a word of prayer? Anyone who wants to lead us in a word of prayer? You can raise up your hand. Okay, yes, Imran.
Um, Good afternoon, everyone.
Good
Let's humble our
afternoon.
souls for the prayer. Almighty Lord Jesus Christ, we thank you for the gift of life that you have given us. We thank you for the gift of parents. We thank you for everything that you have done for us, Lord. Father, as we come before you today, we are praying for the gift of wisdom. We are praying for the gift of knowledge, so that we can understand each and everything that Mr. Kaziba, our teacher, is going to teach us, Lord. And we pray that you might continue to bless him in his work so that he can continue to offer his services worldwide, Father. In the mighty name of Lord, in the mighty name of Jesus Christ, we pray and believe. Amen.
Amen. Thank you so much for the word of prayer. Kindly use the chat to let me know whether there is any number among these ones that I gave you to try out that didn't come out that you want us to go through. Any number, be specific, that this part, and then that is the one I want us to first do before we go in for today's work. You can let me know whether there is any parts, any number you feel did not go on well. No, like be specific because now part I, number 5, part C. Something like that. That one makes the work easy. Number 5, part C. So that is 1. Number 5, part C. That one we are going to do it. Then I'm looking through the chart. Number 5, part C. Number 5, part I, and 5H. Okay, so we are going to do 5I, 5C, and H. So those are the three we are going to do. So allow me to duplicate and, and create some slides. Okay. So here we are going to remain with the this part here. Okay. Okay. So we are going to try out those three, and then we start our session well. Now, when you look at our introduction, we say that whenever we are integrating and doing anything with integration, there are some things we need to know. We say that when we are given an integral, say we are given x power n with respect to x, it means that we are going to integrate with respect to x. And we say that where with x is what we call the integrand. So we say that when we integrate this, we shall have x n plus 1 divided by n plus 1, then plus the constant of integration. Now, they want us to do the first part, part A. We say that in order for us to be able to do any integral, we must first ensure that we have multiplied thoroughly inside, such that we have terms. When you look at these brackets, these are not terms. A term means a term means you have a variable like x and you have a number like 2x. This is the term. So you can only integrate when you have those terms. So for the first one, we have our integral of x plus 1 into x plus 4 with respect to x. The first thing we do, we have to come here and first multiply and open our brackets. So when you open your brackets, feel free to do it as side work. You can put it as your side work, something like this. And then you multiply very well. You open your brackets very well in case you are not yet at that point of multiplying automatically. Then multiply that. This is x squared plus 4x plus x plus 4. Then this will end up giving us x squared plus 5x plus 4. Now, that is the first thing you have to do. Now, after doing that, you will come and then you are going to get this. And then you substitute it with this. So here we shall have x squared plus 5x plus 4. But everything here, we are integrating it with respect to x. That is the first thing we have to do. Now, when you reach there, you can either integrate it at once, or you can separate it. It is okay. Whatever approach you want is what you do. The first one we have is x squared. Now, when you compare here, x is the same. Then the power is the n. So that means that when we integrate, we shall have x. We add a 1 on the power. Then after we divide by the new power. Then when we have 5x alone, we know that this x here has a power of 1. So we add a power on x, which is 1 plus 1 divided by the new power. The same thing will happen on 4. But we said that whenever you have a constant, on a constant, there is a hidden x with a power 0. Because any number to power 0 is a 1. So you add here a 1, then after you divide by the new power. So that is how we integrate individuals. So that means that when we have the integral of x squared plus 5x plus 4 with respect to the x, for the first one, we shall get x power 3 out of 3 plus 5. This is going to be x squared out of 2, then plus 4x plus a constant. Hope that is very okay, everyone. Is that okay now? The person who asked? I do believe that that is very okay now. Now, we go to the second one. People have asked us to do part C as well. So part C, when I clean my board, I'm going to clean this board. When you look at part C here, part C, still, we cannot be able to integrate without having those terms, those individual things. So we have to first eliminate these powers. So for this one, still, first open your bracket very well. This is x squared. And we know this one means you have 2 root of x minus 1 into 2 root of x minus 1. Then you open your bracket. You know when you're opening the bracket, this one multiplies everything you have here. So it will be 2 into root of x into 2 root of x minus 1. Then this one as well, this one here will multiply everything here. So we shall have minus 1 into 2 root of x minus 1. Now, we open the brackets. Now, when we are opening, we open very well. You can first do your thing slowly. So you say this is 2 root of x, and I'm multiplying it times 2 root of x. Minus, this is 2 root of x times 1, which is the same thing, minus 2 root of x minus 1 times 2 root x, you get this. Then minus 1 and minus 1, which gives us a plus 1. Now, remember your knowledge of indices, that when I have 2 root of x times 2 root of x, 2 times 2 gives us a 4. Root x times root of x gives us root x squared. But these 2 and the square root can cancel, so you remain with 4x. So here we shall have 4x minus 2 root x minus 2 root x is the same as minus 4 root of x, then plus 1. Then we say that when you have a root, write it in form of a power. Apply your knowledge of indices. So meaning that here we can write this as 4x minus 4x. When we have a root, that is the same as a half plus 1. But pay attention. In case, let me say you had a power m, and here there was n. Then this one would have been a m out of n. But just because for square root, we always eliminate the 2 here. But that's how it comes about. It becomes x 1 out of 2, because here there is the power of 1. Now, this is what we are going to be integrating. So now I'll come back here and I write my integral of 4x minus 4x power half, then plus 1 with respect to x. So now I can integrate each of them. When I integrate 4x, we shall have 4x, the power is 1 here, so it will be 2 out of 2 minus. Now here, still you'll have 4x power a half. Then you ask yourself, when I add a 1, what do I get? This one becomes 1. Also, this becomes a half plus 1. A half plus 1 is the same as 3 out of 2. So this becomes 4x, 3 out of 2. Everything, 3 out of 2. Now, here is where now you need to do your mathematics well. So remember, this is the same as 4x, 3 out of 2 divided by 3 out of 2. When you do the mathematics of reciprocal, this becomes 4x, 3 out of 2 times 2 out of 3. So 4 times 2, you get 8. So here, we shall end up with 8 out of 3. 4x, sorry, there is no 4, again, because I finished write it. This will become x 3 out of 2, then plus, when you integrate 1, you end up with x, then plus a constant. Now, since in the question we had a root, better also you write this answer in form of a root. Then this 4 and the 2 can reduce, so we can reduce that. So we remain with 2x squared minus 8 out of 3. Then this one in form of that, it will be this. Then here we shall have x cubed. Then plus x plus a constant. These two being a square root, there is no need to put it there. But if you want, you can put it there. So that's how you attempt part C. Any questions on that number? Or it is fine? Is it okay? What if its power is 3? Oh, yes. Priscilla, I don't know whether you are meaning that what if the whole, what if, like the power was 2 root of x minus 1 power 3. Is it what you mean, Priscilla? You can let me know.
Yes, teacher.
Yes. Still, what you do for such a case, you multiply it 3 times. So you will say 2 root of x minus 1 into 2 root of x minus 1 into 2 root of x minus 1. That's how you can multiply it. So, but here you can first deal with the 2 and then you multiply by the 1. Alternatively, I know you remember, I know you have done this kind of solving. I don't know whether you have done it in your schools, whereby you do like this, you put 2 here, you put a 1. You can also use this kind of approach. It is also very fine if you know how to use it very well. More so if at all the powers keep on increasing, let me say the powers are 5, 6, 7, using that can be the easiest solution. Okay, I'm looking through the chat whether must back up the square root, it was there. No, it is not, Melissa, it's not a must. It's not a must, but you can either put it back or not, as long as you have integrated it. But sometimes they may ask you to write it in a specific format. Okay, with 1. I think we did part 1. We did part 1, Marvel, but we said for part 1, I think this is the part you are meaning. Oh, you are meaning I. Okay, I don't know that people meant I. Okay. We are going to, we are going to do part I as well. We are going to do part I. We are going to do part I. I have seen. Okay, Martina, I have seen. We shall do part I. Okay. I'm going to remove this, and then now we are going to go to part H. Part H. Now, part H, here, the first thing we are going to do we are going to first, I want to first deal with this one here in the denominator. What do you do? When I want to just deal with this one down to first simplify it for you. So this is x, root of x. But we know that root of x, what is it? This is x times x power a half. Now, you remember from your indices that x and x, this one has a power 1. So you can make it much simpler. That this is x 1 plus a half, which will give you x power 3 out of 2. That is one alternative. Another person could as well approach it in this format, whereby he knows that this x is the same as having root of x squared, then times root x, which will give us x power 3, and you can have this as x 3 out of 2. Another person could approach it like that. Now, this is what I have in the denominator. Then I come to the numerator. Numerator, I have x power 4 minus 10, everything out of x power 3 out of 2. Now, I told you, still we cannot deal with such. So we are going to divide individual parts. So individual parts means that I'm going to have x power 4 divided by x power 3 out of 2 minus 10 out of x power 3 out of 2. That is the first thing that I'm going to first do. The moment I finish this, okay. So let me hope this step is fine to everyone. Is that step fine? I had muted a bit to allow you to digest. Okay. Is the step fine? Not yet. Someone. Okay, okay. Okay, okay, let me repeat. Now, from here, after separating here, remember your knowledge that if I have, let me say, 1 plus 2, everything divided by 3. I can separate individual. I can have 1 out of 3 plus 2 out of 3. That is what I'm going to do. That's what I've done at this step here. Now, at this step here, I'm going to apply my knowledge of indices. Numbers of the same bases, when I'm dividing, I subtract. So I'll have x 4 minus 3 out of the 2. Then there is a subtraction sign here. So I will say minus. Then there is a 10 up. But you know, when I have 1 out of a power b, this is the same as a power negative b. From your laws of indices, but I know maybe this is what you meant. Also, when I have a power m is the same as, power negative m is the same as having a power m. So this is the law we are utilizing. So when I have 1 out of x power 3 out of 2, this is the same thing like writing x power negative 3 out of 2. So I'll have here x power negative 3 out of 2. So now I'm going to deal with this one. I'm going to deal with this separated. Like 4 minus 3 out of 2. So this is like out of 1. So you can just place it on your calculator. You can just place it on the calculator. So I know this will give you 8 minus 3 out of 2. And 8 minus 3, that will give us 5 out of 3. So you can just place it on your calculator and then you have your answer. So I don't know whether that is okay. So here I'll have x power 5 out of 2 minus 10 x power negative 3 out of 2. Kindly let me know through the chat whether at least we are on the same line. Is that step up to around that point? We have not yet integrated. Okay. Bella says yes. Melissa says yes. Martina says yes. Okay. Okay. Oh, yeah. Good. Now, after now simplifying whatever we have inside, we are going to go on and integrate. So now I'm going to come and I put my integral sign with respect to x, because now I have been able to make a term and a term. So when I come here, remember our integral, we shall come here and say x, 5 out of 2 plus 1. Then I divide by 5 out of 2 plus 1. Minus, this 10 is okay. Then I say x, negative 3 out of 2 plus 1. Divide everything by negative 3 out of 2 plus 1. Then plus a constant. Now, you are going to simplify what is in green. So I say 5 out of 2 plus 1. That one I'm getting 3.5, which is 7 out of 2. So you're going to allow me to write here. So that is going to be x, 7 out of 2, divided by 7 out of 2, minus 10x, then negative 3 out of 2, plus say 1, that is negative a half. So here I'll have negative a half. And also down here, I'll have negative a half, then plus my constant. Now here you can simplify further, but now I want you to notice it very well, that whenever you have a number, let me say m, out of, let me say 1 out of n, it is just a matter of us having this n come and multiply what we have inside here. So this is the same as having 2x out of 7 power 7 out of 2. Then this is the same as having the 2 come up. But also I want you to take note that here there is a negative and there is a negative. So these two negatives, they can reduce and you form a positive. So that means that we are going to come and we shall have a positive here. Then this 2 is going to come up here and we shall have 20 and we shall have x power negative a half, then plus c. Now, if you want, you are going to simplify it further. To simplify it further, it means that I'm going to get this negative a half, I bring it down. So I can have 2 out of 7, x, 7 out of 2, plus 20 out of x power half, then plus c. If you want, this number can be simplified further. Let me know in the chat whether you want us to continue simplifying. Whether you want us to continue simplifying. Can I bring in the roots? Bella said yes. Now we continue simplifying. Now I'm going to, let me remove this part here and I write from there. Now to continue the simplification of this, let me, to continue, I have 2 out of 7, x 7 out of 2 plus 20. But we know that x power half is the same as having root x. So here we shall have 20 out of root of x plus c. Now still this 7 out of 2, I can write it in form of a root as 2 out of 7. Now this root here can become this, then this can become x power 7 plus 20 out of root of x plus c. Something like that. So you can simplify and reach up to that point. kindly let me know whether you have picked something, whether that is very okay. In case there's something, you can let me know where you want me to throw more light. In case there's something you feel I need to elaborate, you can let me know. But if you feel now it is okay, let me know whether we can continue for another number. Mira, can you okay, let me first look for Mira here. Mira, can you unmute?
Yes, teacher, my concern is here around the green part where we have 7 power 7 where we're having x power 7 out of 2 over 7 out of 2. You said
Yeah.
that 2 would come and multiply, yeah, that part there. You said that 2 would come and multiply with the numerator, the 2 which is down there. I think if it is to multiply, like the 2 will cancel out. I will only remain with x power 7. But
Okay.
as we continue, I see that 7 out of 2 still there.
Are you seeing this? X power 7 out of 2 divided by 7 out of 2. Is that okay?
Yes.
Then that means we shall have x power 7 out of 2 times 2 out of 7. Is that fine?
Yes.
So this gives us 2x power 7 out of 2 out of 7. Now, this 2 and this one can't cancel because this is the power. I don't know that is okay, Mira. Is it fine? Not yet.
It is fine now.
Okay. 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 Now I'm going to clean my board. So this is where you can end for your answer. Okay. Now we go to the last part, part I. Now still for part I. On part I, I'm going to first request you to first simplify for me this. Simplify for me this. First simplify for me that. If you want. If you don't want, we can go the way it is. That is the other alternative, going direct. But you leave it. Let's go direct. No problem. But let me first see. There is someone who wanted a pardon. Melitonic. Melitonic, kindly first let me know where the problem is. Simile?
Excuse me, sir.
Yes.
I just joined, but on simplifying x times root x there, I'm confused.
Oh, like
The other
we
parts I'm
say,
okay, but on that part I'm confused.
x times root x here.
Only that.
So this is the same as x, but root of x is the same
Yes,
as x
x
power
power
half.
a
Not
half.
so? So here
Yes,
I'm multiplying times x power half, right?
yes,
But this x has a power 1, true?
yes. We are.
Now, from your
Okay.
laws of indices, a
I have
power
got
m
you, sir.
times a power n.
I have got you, sir.
Okay, okay.
Yes.
Carry. Now, we continue on part I. Now, on part I, remember this is a squared, meaning we are going to multiply the two brackets. So I have 2 root x minus 3 out of x squared into root x. So we are going to multiply it twice. So I'll have 2 root of x minus 3 out of x squared into root x. That is the first step. Then after we open the brackets, so I'll have 2 root of x bracket 2 root x minus 3 out of x squared root of x minus 3 out of x squared root of x whole into 2 root x minus 3 out of x squared root of x. Now from here, we are going to now multiply. So I'll have 2 root x times this. So I'll have 2 root x times 2 root x minus 3 times 2 root x out of x squared root of x minus 3 out of x squared root x times 2 root x. Now this minus here, I don't know whether people are seeing the minus. This minus here and this minus here are going to give us a positive. So the next step, I'm going to write plus. Plus 3 times 3 up. Here we have x squared root of x. Then I have x squared root of x. Are we still on the same page? I want to know whether we are still on the same page. Pavina said, yeah. Okay, good. Now, I'm going to deal with individual parts such that we can move together. The first part I'm dealing with is this part. So I'm going to write it here. 2 root x times 2 root x. We said these 2 and the 2 will multiply. We shall get 4. Root x times root x means have an x times x, which will give us 4 root of x squared. And root of x squared, these 2 and the root can cancel. So you remain with 4x. Alternatively, if you don't want to use this approach, you can just say 4x squared, then times power a half. The 2 and the 2 cancels, still remain 4x. So here we shall remain with 4x. Now we go to the second part, minus this negative. I go to the second part. Now the second part, you are not seeing a root x up and a root x there. Then those 2 can cancel. Then I have 3 times 2 is 6. So here I'm going to have 6 out of x squared. Then minus, I go to the next one. Root x and the root x are going to cancel. So I'm going to remain with 6 out of x squared. Then I go to the last one, which is a plus. Plus. Then when I'm going to simplify that one still from here, I have 3 times 3 up out of x squared root x times x squared root x. 3 times 3 up, we shall have 9. Then come here. X squared times x squared, we get x power 4. Or you can use your indices. Numbers of the same bases, you add. Then root x times root x. I have root x times root x. We have said this one will give us x times x, which is x squared, which will give us x. So here I'll have times x down. So which will give us x power 5. So the whole of this one will reduce to 9 out of x power 5. So here I'm going to come and I put 9 out of x power 5. Kindly let me know whether we are still on the same page on that part. Yeah. Matthias said yes. Mary said yes. Prince, Mary, Martina, Infinix, Emma. Yeah, we are still on the same page. Now, we are going to go on and simplify. Now, I wanted to first simplify this part here, where I have this part here. Are you seeing this part here? Is the one I wanted us to simplify, where I have minus 6 out of x squared minus 6 out of x squared. Now, from your fractions, if you remember very well, if I have 1 out of 2, negative 1 out of 2, minus 1 out of 2, put for me in the chat, what is your answer? Negative 1 out of 2, minus 1 out of 2. What is your answer? Okay, people have got negative 1. Negative 1. Perfect. Very good. Let me. Good. Now, do you know how to do this quickly? Since the denominators are the same, I will just say out of 2. See, whenever the denominators are the same, just say out of 2. Then the ones up, carry them the way they are. Negative 1 minus 1, which will give us negative 2 out of 2, which will give you negative 1. Now, this concept here is the same concept I want us to apply here. Apply and put for me your answer in the chat. First apply and tell me what your answer could be in the chat when you simplify those two. Think, use the same approach I've showed you here for negative half and negative half, and put for me the answer. Love, that is okay. Latif, that is okay. Melissa, that is okay. Priscilla, that is okay. Priska, Bay, John, yeah. Mama boy, that is okay. Ikra, comfort, yes. Now that is the knowledge we are applying. So that means that for only that part, here we shall have negative 6 minus 6 out of x squared, which will give us negative 12 out of x squared. Now, the whole of this, can I clean the board? I don't know that I can clean. Okay, let me just clean. I'm going to take an assumption we are finished. I clean. Yeah, people have said yeah. It is okay. It is okay. Okay. Now I'm going to come here. Let me use another color, not to confuse. So I'm going to come here and say now, I'm going to remain with 4x. This 4x, the whole of this has simplified to minus 12 out of x squared. Then the whole of this has simplified to plus 9 out of x power 5. That is the simplified form. So that is what now we have remained with when we simplify everything. So now that is the simplified form that we are going to integrate. Can I have now someone raise up the hand and you simplify call for me from this point here before we integrate? I want that next simplified form. Anyone who wants to tell us? I want us, when we write those fractions in form of base and power. Yes, Imran. Imran? Oh, okay, I'll fail to get Imran. Anyone? Okay, Imran?
I think I'm going to first consider the 12x squared plus the
Perfect.
9 out of x to power 5. Then I'll multiply my denominator will be x to power 7 because I'm going to multiply the x squared with the x to power 5.
You want to, now I want, now, Imran,
Yes,
I
sir.
want you to write for me this in form of a base and a power. Also this in form of a base and a power, such that we can be able to integrate.
Okay, I'm not understanding you.
Okay, I want you to write it for me in this form. Are you getting it? Not yet. Okay. Let me first have
Oh,
Priscilla.
yeah.
Okay.
So it will be 4x minus 12 x to power negative 2
Good.
plus 9x to power negative 5.
Okay, good. Thank you. Thank you. And this is what we are now going to integrate. Thank you. Priscilla? Okay. Oh, Maria K?
Excuse me, teacher.
Yes.
Does it mean that when you represent it the way Imran had represented it earlier, where he combined the power and he got x to power 7, does it mean that it has changed the whole meaning, or you'd still get the same answer at the end?
Oh, now where Imran was taking us, he wanted to simplify this, something like this, So one of the things here, he is taking us back, like we are going to go back a bit, because this one would have been negative 12 x power 5 plus 9x squared out of the x power 7, of which now this one still, there's then a way you are going to integrate it minus putting it back in the other format, because we said we can only integrate individual terms. But this is a combined one. I don't know that you have picked it, Maria. Maria, is that fine? Okay. Hope that is okay, Maria. Okay. Priscilla?
Yes, teacher.
Okay, Priscilla, integrate for us from this part.
Okay. So we're going to have the 4 the 4 minus, no, the 4x minus.
Integrate, first integrate x, first integrate this one, and then we continue.
It will be out of 1, so it's basically 4, right?
Okay, what is the power here on this x?
It's 1. 1.
1, so remember you add and then you divide by the new power.
Yeah.
So you add for
Okay.
us. What?
4x squared out of
Out of?
x squared.
What is out of? Remember,
Out
you
of 2.
divide by the new power.
Sorry, teacher,
Out
out
of
of
2, good.
minus
Continue.
12x power negative 1 out of negative 1 plus 9x to power negative 4 out of negative 4 plus c.
Plus C. Okay, continue and simplify further.
We shall have 2x squared
2x squared
plus 12x
plus 12x
to
power
power
negative
negative
1.
no plus, see, it's not going to change because 9 can't be divisible by 4.
But remember, this is negative.
Oh, okay. Minus x to power 4 plus c.
Okay. Okay, thank you, Priscilla. Aisha? Aisha, unmute.
So teacher, on the last step, she's making a mistake where we are having, after having the step before the last, where we are having plus 9x power negative 4 out of negative 4. On the last step, we are supposed to have 2x squared plus 12x power negative 1. Then plus, because of the negative, the denominator will affect the plus. Then we,
So which sign shall we
then
have here, Aisha?
we shall go use the negative. Then now after the last step, we shall have it in form of fraction.
Okay, continue for us.
Then we shall have 2x squared plus 12 out of x. Then minus 9 out of 4x power 4. Then
Plus C. Okay. That is very okay. That is very okay. Thank you. Yes, Martina?
I wanted to say what Aisha said about saying 12 out of x, and then 9 out of 4x to power 4. But yeah, she has contributed well.
Oh, okay. Okay. Thank you. You'll give us the next answers. Okay. Okay. Members, can we look at and check whether there is any other number you feel we need to go through, or now all of them are correct? Any number, you can put it in the chat, and then for D, for D, Mira, we did A. Okay. Okay, people are saying, okay, maybe D. Okay, let me first pick Imran. Imran? Imran, you can unmute.
Excuse me, sir.
Yes.
I just want to comment about the first thing that I was going to simplify, the one that consisted the 12 out of x squared plus 9 out of x power 5.
Okay.
Now, on this side where you circled it, when I use the knowledge of indices, I could get the 12x out of 5 out of x power 7. Then using the knowledge of indices, because it's a division, I'll subtract 5 minus 7, getting a negative 12 x to power negative 2. And also the same thing with the 9.
Okay. So
Yeah.
which could take you back here?
Yes, teacher.
Yes. Of which, okay, which is very okay. So when you combine, still you go back to this individual term, because if you have negative 12x power 5 plus 9x squared out of x power 7, and now you separate again, negative 12x out of x power 7 plus 9x squared out of x power 7. This one is going to take us back to the original thing we had. But it is also the same thing. I don't know that you have noticed it, Imran.
Yes, I've noticed it, sir.
Okay.
Thank
Okay.
you, sir.
Okay. So we are going to start with Martina. Since Martina, unmute.
Yes, teacher.
Okay. I think someone wants us to go through part D. So you're going to first simplify for us. Take us through the steps to simplify part D.
Okay. So we can begin by opening the brackets. So we have x cubed. Okay, x. Now it's 8. Down.
Tell me what
3.
to write.
No, it's a half.
It is?
A half.
A half. Now I want you now to look here.
3 times a half.
3 times a half. Okay.
No,
when we
no,
have
not
this,
that. It's a half out of 3.
Out of 3. No. Okay. I want us to first come back here. Are you seeing this? Are you seeing this?
Yes.
Now this one, if we are to simplify it, it becomes m out of a. Is that fine?
Yes.
Now, can you relate it to this and tell me what we are going to write?
3 out of
1 out of x to power 1 out of 3.
Okay. What is your a? When you compare, what is our a here for this case?
It's x.
X, so I will put x. What is your m? What is the power on m?
So it's 1.
1. So I will put 1 out of, what is your n?
She has done it correctly. Okay.
It's 3.
3. So that's how we write it. Eh?
No.
Is that fine?
Yes, teacher.
Okay, now can we continue? Let me first write that one. Continue.
So it's going to be x to power a third times x squared plus 1.
Open.
No,
One.
plus x to power 1 out of 3.
Okay.
And since the x's of the same base, it's going to be addition. So it's going to be a third plus 2 plus x to power 3, x to power 1 out of 3. Then third times
Okay. What do you get?
so I'm going to get 6 out of 3. No,
Okay.
no. 7 out of 3. No. Plus a third.
X power third.
X power third.
Okay, like that?
Yes.
Okay. Okay. So we go to the integration. Integrate for us now.
We're going to say x to power 7 out of 3 plus 1 out of 7 out of 3 plus 1 plus x to power a third plus 1 out of a third plus 1 plus the constant of integration, C.
Okay.
Then 3 is going to give us what? 10 out of 3. So we're going to get x to power 10 out of 3. I'll divide by 10 out of 3 plus x to power 4 out of 3 out of 4 out of 3 plus C.
Okay. Simplify further.
So there. So can someone pick up from there?
Okay. Now okay. Aisha.
So from that step, as we see that we have x power 10 out of 3, but that denominator is dividing, then we shall make a reciprocal by multiplying, and we shall have 3x power 10 out of 3, then out of 10. Power 4 out of.
Okay. Then plus? Yeah. Perfect.
Plus C.
Okay. Yeah. That is very correct. Thank you, Martina. Thank you, Aisha. So that is how you approach. But for those when you reach this point here, you come divide by 10 out of 3. This is 10 out of 3. So that is how you approach it. Yes, so that's how you do this number. So for the rest of the numbers, you are going to do them in your free time. You'll keep on trying. When you get stuck, you can let me know. Yes. Okay. Yes, lastly, Arnold, before we look at something, Arnold?
Good evening, sir.
Good evening.
I was requesting if you could put back how we were working out.
Yes?
What we were working out, I was requesting if you could put back.
To do what?
If you could put back the number working out, part.
Oh, unfortunately, I've cleaned the board.
Okay, sir, I have a question.
But I'll put the recording, yes.
It's okay. My question is, you never reintroduced the integration sign. It's not a must.
Integration, it was there. The C?
Yes?
The C?
No, like at the end.
At the end?
Yes, but the final answer.
Oh, no. Remember, we integrated. We integrated. So the moment you integrate, the sign goes away.
Oh, okay. Okay, thank you.
Okay. Okay. So now you write this. This is what we are going to look at. Write that. Write that. Okay. Okay. We are going to look at, yes, Arnold.
Teacher.
Yes.
It was a mistake. I forgot to lower my hand.
Oh, okay.
Sorry.
So we are going to look at what we call definite integration. Now, we are going to look at the integration, and what we are going to look at now, we are going to look at what happens when we substitute in. On our integral, for whatever thing we have been doing on, we have been just integrating, but without coming up with the real solution. I told you that one of the applications of this topic is to be able to obtain things like area, such things, estimations. Take an example. You're going to be finding figures. Let me say you find a figure, they will give you something like this. And they want you to find the area that has been covered maybe by this. Sometimes you're going to meet, let me say something like this. Let me say this is a lake. And you want to estimate the area. But there is no way you are going to estimate minus you knowing from what point to what point are you estimating. So that is now what we are going to do. That means what we are going to deal with, we are going to deal with the substitution. We are going now to substitute whatever thing we are going to do. We are going to substitute inside the answers. So whenever something is definite, it means number one, we are going to put in our limits. For any integral that we are going to deal with, this is my integral. Down here, this number, which I can call A, is what we call the lower limit. This number up here is what we call the upper limit. And we say that what we have here is always what we call the integrand. So what are we going to do? Take an example. I can just give you an example. In case I have a Cartesian plane, and now they want me to estimate the area of something like this. In case they want me to estimate the area of this part, I will know that if I'm to estimate this area, this is my x-axis. So I will know that I will start from this point here up to this point. Now, the starting point is what we call the lower limit. The ending point is what we call the upper limit. So we are going to be dealing with such things, substituting and finding out the solution. So the first one I'm going to ask you to integrate for me this. Everyone is going to integrate. Integrate for me this, and my limits are going to be 1, 2, 3. I want you to first integrate, but let us first do it together. We know very well when we are integrating. Now, please take note. Whenever you find that you have a lower and an upper limit, we do not write that constant of integration, because now here we know where we are going to end. So we don't write it. So when we integrate this, we know that the power, we shall add 1 on the power. So we shall have 2 plus 1. Divide by the new power, which is 2 plus 1. Now here we don't add on the constant of integration the moment you find that you have that power. So here I'm going to just put a line to show that I'm going to integrate from 1 to, I'm integrating, or my lower limit is 1 up to 3. So this will give me x power 3 out of the 3. Then my limits are from 1 to 3. Now what does it mean? It means that I'm going to opt to put or to substitute my 3. Always, we start with substituting the upper limit. So I'll substitute the upper limit, which is going to be wherever there is x is where you put 3. So I'll have 3 power 3 out of 3 minus the lower limit, which is 1. So it will be 1 power 3 out of 3. Then I'm going to continue 3 power 3. That is 27. Divide by the 3. So here we shall have 27 out of 3 minus 1 power 3. Remember, you are only cubing the x. So it will be 1 out of 3. So then 27 minus 1, that is 26. So I'll have 26 out of 3. And when I reduce 26 divided by 3, I end up with a fraction. So my fraction here is going to be 26 out of 3. So I end at that point. So that is my area. Let me know through the chat whether we are on the same line. Okay. Yeah, it is okay. Let me pick a hand. Yes, Mohasimin.
Sir, good evening.
Good evening.
I was inquiring about the miners. Where did the miners come from?
Oh.
After cubing the 3,
Hmm.
3 to power 3 divided by 3 minus. But this minus, where does it come from?
Okay. Now, where does the minus come from? Now, the minus comes because we have two areas. Yes, let me, I don't know whether I can use, let me give you an example here. I'm going to just use this line, and this line is running up to 3, and I'm going to give you this, and this is 2.
No, Bernard, man, decrease your stuff. Decrease the volume. Let me change the position.
Hope you are seeing my figure here. Now, this is my figure. I want to explain this. Now, when I tell you, or when we are calculating, you are saying this is my trapezium. When I'm calculating I want to derive for you how that thing comes about. Now, when I tell you to integrate or to find for me the area covered by this, are you seeing covered by this? You know very well that this line here I have drawn is the line we call y is equal to x. I've just called it x. Now, when I tell you to integrate, you are going to integrate x, but you are going to start, since I want this area in black, it's going to be from 2 up to 3 with respect to x. Now, when something like this is what we are going to have. But you are not seeing that this 3 starts from 0. So you are running from 0 up to 3. That is the first thing. Then 2 means that you are going to run, let me put it clearly here such that you can see, you are going to run from 0 up to 2. So in order for us to get this part that is remaining here, it means that you subtract the 3 minus the 2. So that's why we subtract the area of the upper limit minus the area of the lower limit. In other words, we are running from 0 to 3, and here there is a 1. So running from 0 to 3, that is the first area. But we have, since we want from 1 to 3 strictly, we have to remove this one. So that's why we subtract. I don't know whether that is clear. The person who asked, Mohasimin, is that clear?
Yeah, that's clear, man. I'm getting.
Okay, yeah. So that is how we do it. Okay, Melissa?
Good evening, Master.
Good evening.
Master, I would like you to pardon on the number because I haven't understood.
Oh, we are going to do another one, eh?
Okay.
Okay. Now, why I'm leaving it in fractions, I don't want decimals, unless they have told you to do so. But in case even you are writing decimals, you make sure you write only at least 4 decimal places. We do another one. I have an integral of x squared minus 1 with respect to the x, and I'm integrating from, I'm going to integrate from 2 to 5 with respect to x. Can I have someone to integrate for us that function? I don't know whether we have any boy. Let me see whether we can. Okay. A boy, okay. Imran, oh no, Gilbert. Gilbert?
Yes, sir. So we shall first integrate the x, that is x to power 3 out of 3. Minus x. Yeah, minus x.
So we said here we don't put, the moment you see limits, don't put the what? The C. Very good. So we are integrating from 2 to 5. Now.
Then you substitute the 5 in x.
X.
That is 5 to power 3 out of 2.
Out of 3?
3 minus 5. Close brackets. Then minus 2 to power 3 out of 3 minus the 2.
Okay. Continue.
Then that is 15. 15 out of 3, that is 5.
Oh. Repeat.
Sorry. That is 125 out of minus 5. Then close brackets minus, that is 8 out of 3 minus, since brackets are still there, 2. Then when we open brackets, that will be 125 out of 3 minus 5 minus 8 out of 3 plus 2.
Yeah. Can we just put everything in the calc and get the answer?
Yes.
Okay. What are others getting?
I'm getting 36.
36.
Yeah. Yeah, that's.
Teacher. Sir.
Yes, Arnold.
I was inquiring where the X came from.
Which X?
I think there where it's written X cubed out of 3 minus X.
Hey, now
Yeah,
minus 1 has a hidden X power 0.
Yes.
So when you add a 1 here and divide by 0 0.1, 0 plus 1, you end up with minus 1x.
Yes.
So that's where the
Okay.
x came from.
Okay, thank you.
Okay.
Yeah.
Okay. People getting 36, that is okay. Okay, let me pick one hand as I turn on, I go to another screen. It's happening. Okay. Yes, Abu.
Yes, sir. I was inquiring to know as we are integrating. No, first go on that slide. I wanted to ask on.
Hey, ask. I have deleted. It is okay, ask.
As we are integrating.
People, we are trying part B.
As you are indicating that we are integrating with respect to X, should the numbers be in brackets or you can leave the dx outside?
As long as you have finished to separate them into individual terms.
Yeah. Yes.
As long,
I thought we should indicate
as
everything with respect to X.
No, now, okay, the moment you put this integral, integral means like the sum. So anything you put here, any differential you put here, it shows that anything within that integral must be integrated with respect to X.
Oh, okay.
All right. Okay, members, can we do part B? Part B. Okay, Muhasimin.
Okay, sir, I was just asking about the previous number this guy has just done. Just that you did the what?
No, okay, talk.
These two here, after calculating from 5 cubed by 5 minus 5, close the bracket minus 2 to the power 3 divided by 3, and then minus 2. Where does that 2 come from?
The two. Oh. Okay, I don't remember how the number was, but I think the limits were running from 2 to something, right?
Yeah, running from 2 to 5.
2 to 5. And what was inside? X squared?
Minus 1 dx.
So this, remember, it was x3 out of 3 minus x. Is that okay?
Yeah.
Now, where there is x is where we substituted the 2.
Oh.
Remember, wherever you find x, you substitute your limit.
Yeah, I get you now.
Okay. Now, members, I want to see whether we have picked something. I want to see which answer we are getting for part B. For part B. Rachel, Bella, Emmanuel, okay. Let me see whether Emmanuel is okay to take us through at least also. Emma. 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 Oh, Emma is not talking. Okay. Is everyone getting that answer? Awesome. Gloria, Kevin, Esther, are we getting that answer? Helen Divine, Jamila, Jane, Jesse Baby, Habib, Stella Kisache. Do we have the same answer? Now, Mariam, Mary, Matthew, Melissa. Do we have the same? Queen, Priscilla. Okay. Okay, according from the chat, Latif, can you unmute?
Yes, I'm unmuted.
Yes, you take us through how you have come to your answer.
Okay. I first started with simplifying.
Okay.
That's by bringing the x power 3 up. So it was 4x power negative 3. So that we had to add plus 1. That is 4x negative 3 plus 1 over negative 3 plus 1. Then it gave us 4x power negative 2 over a negative 2.
Okay.
Then what I did was this negative 2 and this 4 here, I divided them to give us a negative 2, x power negative 2.
Okay.
And since you said to get the area, I had to use this upper limit and the lower limit. So what I did, I couldn't get this answer with the power of x as a negative. So I decided to bring it down. I wrote it as negative 2 over 3 squared over what? Over x squared.
Okay.
So then by putting the upper limit and the lower limit, subtracting them, I wrote it as negative 2 over 3 squared minus the negative 2 over 1 squared. Which really didn't work out for me because the final answer would give me a what? A 0 over 9.
Okay, negative 2 out of 9?
Out of 9. Minus negative 2 out of 1.
Okay. Negative 2 out of 9. Plus.
And from there.
Remember, this is a fraction. and you are adding it to a whole number.
Yeah, I've seen my mistakes. I've seen my mistake.
Yeah, so that is where the mistake was.
Okay, thank you.
Okay. So here you'll end up with 16 out of 9. Let me hope that is very okay, everyone now. Okay. Maria K. We are going to do for me this part D, and let it be our last part D. Let's do part D. Yes, Maria K.
Excuse me, teacher.
Yes.
Why can't you put the limits on that step? Could you pardon on why you cannot put the limits on the on that step where they were like negative 2x to power negative 2?
No, Maria, you can, given that you are very good at indices. So that one you need to be very careful, because to be this minus negative 2, then times your x, which will be 1 power negative 2, right?
Yeah.
So this will be negative 2 times. Now, you need to know that 3 power negative 2 means 1 out of 3 power 2, which is 1 out of 9.
Yeah.
So this, now here, it reduced to negative 2 out of 9 minus, this is minus 2. This is 1 power negative 2. So you need to know 1 power negative 2 is the same as 1 out of 2, which is 1. So this becomes negative 2, which takes you back to negative 2 out of 9 plus 2, which will give you the same answer.
Oh, all right. Thank you, teacher.
So it is up to you, as long as you know how to deal with them. Okay, so can we try part D?
Yes, Peter.
Now, when you get a negative, it is okay. The negative is an indicator where that particular area is lying. So in case you get a negative, do never worry. I know, but in case you are getting it for this number, then you need to check out. So when you get negative, sometimes it indicates that it is below the x-axis. Now, for this particular number, people are getting 21. Okay? Check out everyone. Now, for this particular number, when you look at the graph, roughly, that graph will look like this, something like this. That's how it will look like roughly. Now, when it looks like that, they're asking you to integrate from 0 to 3. So this is where 0 is, and this is where like 3 is. I'm just assuming. Because when somewhere here, so they just want you to find out the area for just this part. That is the meaning. That is the meaning for that. In case you find that maybe they have told you to integrate x squared, something like this, it means they want you to find the area. You know that that graph will look like this. So in case they say from 0 to 4, it means they want you to integrate from 0 up to where 4 is. So they want you to find that area. That is the meaning. Okay, so I want to look in the chat and I confirm that everyone is getting 21. Very, very good. Very good. Now, For the rest of the numbers, let me just, okay, yes, Latif.
Master,
Latif?
I was asking, what do we equate the answer to? Do we equate it to y or do we equate it to area?
Which one? No, you just continue with your integral. That the integral 0 to 3, 10 minus x squared dx will equal to, this is 10x minus x power 3 out of 3. From 0 to 3. Then you continue working out and substituting.
Like I'm saying, if you have got your final answer now.
Hey, your final answer, you equate to this one. That this one is equal to 21.
Okay, thank you.
Okay. Okay, now I was of a view. Why don't we do the rest of the numbers in our free time as we practice? What do you think, members? The rest of the numbers. You sit down, you try call your numbers. Yeah. Then when I get time today, I'll put for you the solutions and then you check out. Then when we meet again, you let me know that this number didn't come out, this one didn't come out, and then we go through it. Hope that is okay. Okay, blessing, I said yeah. How did you get 10x? 10x came from here. Remember, you had an integral. 10, we said it has x power 0. So when you have to integrate it, add a 1, divide by 0 plus 1. So which gives us 10x out of 1, which is 10x. So that's how we get it. In integration, any constant carries the x, any constant. Okay, in case you have a question, you can ask. But if you feel we have answered the questions, then we can start from there when we meet again. May I wish you a good evening? Yes, Muhasim.
Master,
Yes.
I was asking if me, I offer physics. If there's a, would we like get some physics lessons, maybe?
Physics lessons, I think it is possible. Let me check on the teachers who can help us. One of the teachers is here. So I'm going to talk to them and then we see whether they can have some time next week.
Yeah, and another thing is that we appreciate your work. Thank you so much.
You're welcome. Yes, Gilbert.
Master, for me, I have one question about this. Like when we are integrating, when we are given the limits. We had not yet covered this topic, but we had to look at some simple integration under probability. And we were told that that part there, after integrating, or when you are integrating, you are told to carry like square brackets, then we indicate the upper limit and lower limits. That second step, is it also, is it correct or?
Yeah, it is very okay. As long as, if you want, you can use these ones. As long as you indicate that you are putting the limits from the lower to the up.
Okay, thank you, sir.
Okay. Yes, Aisha. Aisha, you can unmute? I think you can. Okay. Heron, unmute. Oh. Okay, Helen, unmute.
Good evening, teacher.
Good evening.
I'd just like to ask, when we're doing these numbers, are we finding the constants of integration?
No. Now that part of finding the constant of integration, we shall do it when we start applications. When we start applications of displacement, velocities, and the rest of that, that's when we shall bring in how to find the constant of integration.
Okay.
Okay. Priska?
Well, teacher, for me, I request for the previous slides to take a screenshot of the question. Then also, inside the biology scholars, we also need a lesson.
Yes. Okay. For biology, we shall have next week. It was, yeah, next week. Teachers, the person who was supposed to take on biology had an activity. So we shall have a lesson next week. We shall have those lessons for biology on the timetable.
Thank you,
Yes.
teacher.
Okay. Priska and Marvel. Okay. Melissa. Danny Marvel. Okay. Aisha. Bella, unmute.
Okay, teacher, we really appreciate your efforts, but teacher, when are we having physics?
You are saying?
We appreciate your efforts, yeah, but teacher, when are we having physics?
Physics, we may have it next week.
Okay.
Excuse me, teacher.
Yes. Yes. Okay. Nyombi. Okay, I'm fading. Melissa?
Inquiring. Is it possible to get a negative one when you're doing in your solutions that you get?
Yeah, you can get a negative, but mainly when you get a negative, it's just an indicator that your area lies below the x-axis.
Oh, thank you.
Okay. So, Melissa. Okay. So, we shall start from here. When we meet, let me wish you a good let me wish you a good evening, and thank you so much, Teacher Farida. Yes, so I wish you a good evening, and bye-bye, everyone. Okay, I will share the questions on the chat.
Okay, thank you, sir.
Yeah, we shall also have chemistry. We shall
Thank you,
also
sir.
have any subject that was not there, you are going to have it. But I know we have chemistry, I think tomorrow. Yeah.
Yes.
Okay.